Okay, we're going to take a look at solving this polynomial equation. And what we would normally like to do is just factor this. I would try to do factor by grouping with the first two terms and factor by grouping with the second two terms. But when I try to do that, I don't get a common term if I try to. I'm just going to put it up here, but this is really not part of the problem. If I take x squared out of the first term, I'm left with x plus 3. And then what factors out of the second term is second set of terms is minus 2, and I'm left with 11x plus 12. These don't match, so I can't use factor by grouping as a method. So that's no good. So no good. So that means I have to use some other method to solve for the x-intercepts or the roots or the zeros of this function. And so we're kind of getting into what we would consider the guess and check method. I'm going to find one that works, divide it out, and then from there hopefully I'll have something that's factorable. So I'm going to go back to rational root theorem and Descartes' rule of signs. Now, what you'll see is going to happen is I'm going to do the rational root theorem, I'm going to do Descartes' rule of signs, it's going to give me a list of numbers to start with, and then I'll start plugging those numbers in and see which one works. Nobody's forcing you to have to do it that way. You could just start by plugging numbers in if you're going to plug numbers in anyway, but this will just limit the possibilities of numbers that you could plug in. So let's go ahead and start with that. Remember with the rational root theorem, we need this number, which is p, and this number, which is q, and so this number right here, which is the number 1. So, and then we're going to list out all of the factors of p and all of the factors of q. So in this case, q is the number 1, so it only has plus or minus 1 as a factor. P is negative 24, so it has a lot of factors. It has plus or minus 1 with plus or minus 24. It has plus or minus 2 with plus or minus 12, plus or minus 3 with plus or minus 8, and plus or minus 4 with plus or minus 6. And those are all possible factors. And then as we go through the rational root theorem to decide what the possible factors of this function could be, the possible roots, we do each p divided by each q. And lucky for us, the only q we have is plus or minus 1, so it's just going to divide evenly into each of these. So for example, if I did plus or minus 1, right, we're doing p over q. So if I did plus or minus 1 over plus or minus 1, that leaves me with plus or minus 1, okay? And then 1 divided into 2 is 2, 1 divided into 3 is 3, 1 divided by 4 is 4, all of them with plus or minus. So the list of possible zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. And to be honest with you, we could stop at this point and not even use Descartes' rule of signs. We can just start plugging in numbers and see which one works, because these are the only possibilities that work. But if we want to take it a step further to eliminate some of these out, we could. And so that's by using the Descartes' rule of signs, and that means we're going to check to see how many sign changes there are. So here is positive. It's still positive when we get to here. When we get to here, it's negative, so that's one sign change. When we get to here, it's still negative. So that means as far as the positive roots go, there was one sign change, so that means there's one positive root. Okay, now we'll do the same thing, but we have to plug a negative number, a negative x, in for all of the x's. So to find the negative one, we'll go negative x cubed plus 3 times negative x squared minus 22 times negative x minus 24, and simplify that out so that we would have, this is going to be negative x cubed. It'll stay negative because it's an odd power. and then squared will be positive because it's an even power, 3x squared, minus and negative will multiply to be plus 22x, and then keep the minus 24, okay? And then we'll check for the sign changes here. This is positive, it becomes negative, that's one sign change. I'm sorry, this is negative and becomes positive, that's one sign change. Then it stays positive, and then it's positive and becomes negative, so that's another sign change. So that's two sign changes total. So for the negative roots, we can have either 2 or we can have none. So that's when we make our table for the Descartes rule of signs. We make our table to see what the possibilities are. Okay, so we could have positive, negative, and complex roots. Okay, and total number of roots we have to have is the same as the degree, so we have to have 3 total. And so our options are, we know for sure we have to have 1 positive root, and then we can either have 2 negative and 0 complex, or we can have 0 negative and 2 complex. So like I said, you can go through all of this and it just kind of narrows it down a little bit. I know that only one of these positive numbers work, so once I find one positive number, I know none of the other positive numbers will work. But you don't have to necessarily go this far. You can just start plugging in from here if you want. So now we're going to decide which of these values do work and give us is a 0. And to find out if it's a 0, we're going to use the remainder theorem. Now, the notes go through and make you do synthetic division for each one, which makes really no sense because the remainder theorem, if you plug it in and get 0, you know it works. And if you plug it in and don't get 0, then you know it doesn't work. So that's a whole lot of extra work for no reason. So I'm going to use the remainder theorem, and I'm going to show you how that works. And I did erase all that, so we have more room. So we're doing f of x equals x cubed plus 3x squared minus 22x minus 24, and I knew my numbers were plus or minus 1. I'm just going to, you know, they're all plus or minus 1, 2, 3, 4, 6, 8, 12, and 14. All of them are plus or minus. Okay, so we're going to just start checking. We're going to start with 1, plug it in, see if we get 0. If we get 0, it's a root. If we don't get 0, we're going to move on. And I know one of these numbers, one of these positive numbers, has to be a root for sure. I'm not for sure about negatives because they could be negative and they could be complex, but I know for sure one of these numbers has to work. So let's go ahead and plug in 1. F of 1 equals 1 cubed plus 3 times 1 squared minus 22 times 1 minus 24. And you can go plug that into your calculator, but by the magic of Miss Roy, who's already written it out and done it already, that comes out to 42. And so this is not a root. 1 is not a root of this function because it has to come out to 0 for it to be a root. So then we'll keep going. Let's try 2. 2 cubed plus 3 times 2 squared minus 22 times 2 minus 24. That goes into your calculator, and by the magic of Mrs. Roy math, it comes out to negative 48. And nope, that is not a root because it didn't come out to 0. So then we'll try positive 3 and see if that works. F of 3 equals 3 cubed plus 2 times 3 squared minus 22 times 3 minus 24. Again, I've already worked that out, and I know it comes out to negative 36. So no, this is not a root. All right, so let's keep going. I know one of these numbers has to work. Okay, so we'll try 4. 4 cubed plus 2 times 4 squared minus 22 times 4 minus 24. Again, by the magic of Mrs. Roy math, and I'll actually tell you this one is 64 plus 48 minus 88 minus 24 comes out to 0. So yes, we found our first root. Okay, so x equals 4 is a root, or 0, however you want to remember it, which means that x minus 4 is a factor. Okay, so that's our first factor. We found it. Now we could keep going. We know that there's no more positive roots because there could only be one. So now we could go through and check all of the negative ones and see which ones work. But that will take a lot of time. Once I find one, I should be able to use synthetic division, divide it out, and see if the rest is factorable. So we'll go ahead, because once we get down to a quadratic, we can either factor it or use the quadratic formula. So let's go ahead and do synthetic division. We'll put the 4 in the box because we know that the 4 is a root, and then we'll use all of the coefficients. So in front of the x cubed, we had a 1. In front of the x squared, we have a 3. In front of the x, we have a negative 22. And then our constant term is negative 24. And if you remember how to do this from the beginning of the chapter, we'll bring down the 1. 4 times 1 is 4. Then we're going to add those together. 3 plus 4 is 7. 4 times 7 is 28. We'll add those together. That comes out to be 6. 4 times 6 is 24. And when we add negative 24 and 24, we get 0, which we should because we already know the remainder is supposed to be 0 when we checked it before. So now I have factored out the x minus 4, and my equation is 1x squared, because it's going to be whatever x is less 1 power from what we started with. So if it was x cubed, we factored one whole thing of x's out. 1x squared plus 7x plus 6. And now that we're here, we can factor it the rest of the way. So I'm going to factor factors of x squared are x and x. 2 factors of 6 that add up to 7. I would go 6 times 1. So we'll have, and we want them to be positive, so we get positive 7. And so those are our other 2 factors. So this equation here, completely factored out, factors to x minus 4, the first factor I found, and then x plus 6 and x plus 1. And we're almost finished. Now to find the roots, we set this equal to 0. And then we have x minus 4 equals 0, x plus 6 equals 0, x plus 1 equals 0, and each one solves, so we have x equals 4, x equals negative 6, x equals negative 1. And those are the 3 factors we've completely, or the 3 roots we've completely solved and found the zeros for this equation. I know there's got to be 3 because of the degree. And then the next step they ask you to do is just do 2 quick little checks. You can graph this equation in a graphing program. I have one that I really like to use called Desmos.com. And I'm going to go ahead and just click over so you can see it. So this was made on Desmos.com. And you can see when I put the equation in, it shows me the 3 roots, negative 6, negative 1, and 4. Okay, so definitely that's just a quick way to check. And then the last thing they wanted you to do as part of this process was plug those 3 numbers in and check to make sure that they work. So I can just do that over here on the side. But when I check for those 3 answers and I plug in, well, we already did 4 because that was the first one. We plugged in 4, we got 0. When I plug in negative 6, remember our equation was x cubed plus 3x squared minus 22x minus 24. I want to get 0 for all of my answers. So we'll try negative 6 cubed plus 3 times negative 6 squared minus 22 times negative 6 minus 24. And when I check that, it goes negative 216, again by Miss Roy's Magic Math, because I did this already in my calculator, so that you don't have to wait for me to plug it in there. 132 and minus 24. That one checks out and goes to 0. And then when I check negative 1 as well, negative 1 cubed plus 3 times negative 1 squared minus 22 times negative 1 minus 24. We end up with negative 1 plus 3 plus 22 minus 24, which is also 0. And so that is pretty much the whole process from start to finish. Again, you can kind of pick and choose how you want to get to your final answer. Once you get to the rational root theorem and you have your possible points, you may decide that there's enough of them or not so many of them that you just want to skip over the Descartes rule of signs and just start plugging in. If it looks like it's relatively simple numbers and you just want to start plugging in from the beginning, the main key is that you need to find one number that works and then use synthetic division to divide it out. And then don't forget that you can use the graphing calculator to check your work.